Okay, so now that we know about exceptions, let's talk about file I/O. Input-output is a really risky business because you're relying on things outside of your control. So this is a prime place to use exceptions, and most of the file I/O objects in the various packages require you to use exceptions. So just like AWT and Swing, the initial Java I/O packages were supplemented with the NIO or new I/O packages. Um, and so these are going to be places where you find the classes that you need to do um, reading and writing to files. Uh, as was mentioned earlier in this series of lectures, the I/O exception that all of these things throw is in the Java I/O package. Okay, so our main objects to concern ourselves with for right now are the file object and the path object. File is in java.io and it provides information about files, and we need to keep in mind that to Java, a file can also be a folder or a slash directory. So that's because Java was made by Sun Microsystems. It was working on Unix to a Unix operating system. Everything's a file, directories are files, and it's handled differently internally. Sort of the newer version is the java.nio.file.P path, which is a more modern update on the way to do this sort of interaction. And file is actually a class, path is an interface. So we can have objects of path type, but then things are implementing the path interface. And whereas file is a class that has workable, executable code with it. And then finally, java.nio.file has objects called files, plural, and paths, plural, and these are classes that are used for dealing with the objects. Now, when we're talking about I/O, we need to talk about readers and writers, and we talk about streams of bytes. These streams are not the streams that are talked about with lambdas, which is another unfortunate overload of terms. So we're going to talk about file readers, file writers, and then for one of your exercises, I'm going to ask you to write a code that writes binary files, and for that, we're going to be dealing with streams. So readers and writers are based around the char type. That's either an ASCII character, a single byte, or a Unicode character, 2 bytes. But the nice thing is when you write something out, it is text. You can open up that file in a text editor and you can see what you've written. You can edit that text file and then you can do a file reader, and you haven't munched anything up because it is just text. It's up to the Java program to then do something with it. If we're working with streams, we are actually writing byte data. So for example, with a writer, you're writing character data. If you write an uppercase A, you are going to see the character uppercase A. If you're writing a stream and we're writing byte data, what you're going to see for an uppercase A would be, I want to say it's hex 40, or if it's a decimal value, it'll be 65. I'm sorry, it's hex 41, or if it's a decimal value, it'll be 65. So, it controls, it has the impact of what kind of how the bytes patterns are interpreted even. There is a project in our folder called addressbook.io, which will show the readers and writers, so we can actually build out your address book and write it out to a file and then see the file and then read the information back in. So when we need to work with a file, need to write to a file, we can't just write to a file. We have to first establish a connection and open the file. And we need to open that file for writing. Then we actually have to write the data to the file. And then we want to close the file so that the operating system is in a good state. Opening, writing, or closing can all lead to errors, and they can all throw I/O exceptions. If we are working with text, we will use the file writer class. And so let's see if we can look at an example of that. So we're going to have it in a try-catch block, and we're going to catch the I/O exception if something goes wrong. And what we would do is we would have the name of a file. If we're working with, string information, that should be the name of a file or a path plus a name of a file. And we're going to pass that into the file writer constructor, and we'll get back an object of type file writer. And what you do is, instead of like a system out println, we would ask our writer object to write, and then just whatever is the string or character data we would like to write. And instead of showing up on screen, it shows up in the file. And eventually we're done writing all of our information, and we tell that writer object that it is okay to close the file at that point. Seems pretty straightforward. There are some different ways to go about that general process. So here we have, backing up for a second, here we have an open with an explicit close. But there's also this try with resource methodology. And this was added later in Java. I don't recall which particular version, but it's been around long enough that you should expect to see it. And one of the perennial problems is that programmers will often forget to close their files, so they just decided to make it something that Java manages for you. So what you do is you specify that you would like to try to do certain things using the try statement, and then pass the name of the object you want to use. And when you successfully complete that try block, it will close it for you automatically. Or even if you unsuccessfully complete that try block, it will close it for you automatically. So this is under the heading or notion of automatic resource management. Don't let your system have the programming language work so it doesn't let your system get into a catastrophically failed state. So the difference between the other version and this, the try with resource, is that we will initialize the writer object as a clause to the try statement. We would like to do this, and then we're going to write it, and if we successfully complete, it closes it. If we catch the object, catch an error, it also closes it. So this gives us a way to be a little bit more concise in our coding, and there's less of a burden on the author to remember to close in either instance. We can also read from a file. You're used to reading from the keyboard, but we can just have a series of data on individual lines, or depending on the structure of the file, and tab separated or comma separated, and we can slurp that into our program by using a file read. One way to do that is using a buffered reader. Buffered readers are used to read a series of characters up to the next new line. And the basic structure is we're going to open the file for reading, then we're going to read a line or read the lines from the file. And when we are done reading the lines from the file, we will then close the file. As with writing, at any one of these points, you could generate an I/O exception. When we create a new buffered reader, there is a call to when we create a buffered reader object, we need to call new buffered reader in the Java NIO file.files class. And in addition to creating the object, we have to specify how is the information encoded. Two common encodings are US ASCII, and ASCII again is American Symbolic Code for Information Interchange. It's the underlying plain text format that predates Unicode. and then ISO International Standards Organization 8859-1. So you can search both of those terms online and you can see what these character sets are. So let's look at text input from the file. We would specify the char set, so we can make a variable of type char set, and we would like, char set to be the char set for name, whatever the appropriate character set for us would be. We would create a path object, asking the paths plural to get the file, and then try with resource. We would like to make a buffered reader object from the files. We'll make a new buffered reader for this file with this character set, and then do our work. And then if we have a file not found exception, how do we deal with it? If we have an IO exception, how do we deal with it? You can look at tech support IO to see this in action, and I recommend that you go through with the file read, set a breakpoint, and just kind of make sure you understand what is happening and maybe contrive an example where you break the file name so you can see the jump to the catch block and a couple of other things there. So we can also do text input from the terminal, and you're probably more familiar with this because in CSIT 103 or 105, you probably set up the reading from scanner with system.in. System.in is just another file as far as Java is concerned. It's just a file of interactive content from the terminal. So, text files are input streams. The terminal is an input stream. You can have network data coming in as an input stream. So this is just another way to process it. If we're going to wrap system.in, the modern way to do that is with Java utils scanner class. And that replaced a much more cumbersome buffered reader methodology that was before it. So this lower one down here, scanner, make a new scanner object from system in, is nice and concise. Before the scanner object existed, the upper line here is what you had to do to read from the terminal, and it freaked people out. I remember reading it the first time. It's like, why do I have to go through all of this just to read from the input? This is nuts. But looking at it, I need an input stream reader from system in, and that input stream reader is going to be passed to the buffered reader, and now I can actually read this. So the idea is this reads character by character, and this reads groups of characters. The scanner is so much simpler. The nice thing about the scanner object is it has utilities built into it, methods built into it for parsing input. So we can say grab the next integer or grab the next line. And it has different constructors, whether we pass it a string or a file or a path argument. So it's, again, really flexible for setting up input. So that's kind of just a rough overview. The best way to work with files is to roll up your sleeves and start getting to work. So let's wrap this up and turn you over to your project. I/O is inherently risky, and there are going to be errors, and you're going to need to use exceptions. So this is a great time to take these two pieces and put them together. But more generally, if you're writing any kind of interactive system, whether it's computer to computer, person to computer, all of these things, they're going to be steps and processes that go wrong, that are outside of your control. If you can anticipate them, use a checked exception and try to recover. It's always best to say, oh, something went wrong, let's keep the program running. But also know that if your internal state of your program gets too out of hand, that sometimes the only thing you can do is crash, but you want to crash gracefully. In terms of file I/O, for input-output, you're going to want file reader, buffered reader, file writer, scanner. But I'm also going to ask you to do some work with the stream classes so you can get a little bit of practice working with binary read and binary write. Finally, the newer path interface is an alternative to the older file object, and you will see both depending on what kind of project you inherit. And if you don't use try with resource, remember to issue a closed statement yourself. Never leave your files opened but not closed. The operating system will almost always close them for you, but in the times where it doesn't close them, that's when the file becomes unreadable and your data gets lost. So don't rely on the OS. Make sure that you're doing it either by using try with resource or explicitly closing the file on your own. Okay, I hope you're ready to do some exceptions, work with some exceptions, do some file I/O, and complete chapter 14. I'll see you in the next week.